Hi guys. So just a little review, but about what we did yesterday. So we're solving quadratics by factoring, and we're using the zero product property to help us. So what we're going to do is factor, which is rewriting as a product, and have that set equal to 0 so that we can use the zero product property to find our answers. So I'll just go over how to do number 5 again. So it looks like it's factored over here, but that's not completely factored. That's just one part of it. We need to, since we have pieces over here, we need to distribute this and then refactor at the end. So x times 4 is 4x. X times negative x is negative x squared. Still equal to 4x minus 49. And then we need to get all the terms on one side. You can take these terms to this side, which would make this a positive x squared. Or you can take all these to the left side and then times by negative 1 to get rid of that. Either way is fine. In class, we took them to the left side times by negative 1, so I'm going to do the opposite this time. So I'm going to be left with negative x squared on the left side equal to the 4x's cancel out. So you get negative 49 on that side, and now I'm going to add x squared to both sides. And so I get 0 equals x squared minus 49. So if you notice, that's a difference of squares. So it factors to be x minus 7, x plus 7. And so again, zero product property says if you have two numbers, which we're treating the whole binomial as one number, equal to 0, their product equal to 0, then one of them must be 0. So there is a value for x that makes this 0, and there's a value for x that makes this 0. The reason there's two different answers is because these are two different factors. So there's two possibilities. So either x minus 7 is equal to 0 or x plus 7 is equal to 0 to make this statement true. And then you just solve for x. And yes, it's just the opposite if and only if it's 1x. So minus 7, x is equal to negative 7 and positive 7. Remember, we talked about the other way was if you have a difference of squares and you have just x squared, no linear term, even if it's not a perfect square, if it wasn't 49, but it was a different number, that would work too. You can also solve it this way. So I'm going to take this down here, and I'm going to add 49 to both sides so that I get 49 equals x squared. And now to solve, you can square root both sides. But remember, since you took the square root, you have to remember it could be a positive or a negative of that number equals x. So again, if this was like 50, your answer would be the square root of 50, plus or minus square root of 50. So that would be an example of when we don't have nice answers. Okay, let's do number 6 here. Again, I know we did this in class. Look for greatest common factor first. There's not, so this one's not very nice to us. You can guess and check. Or we know that the two numbers that we split this 34x up into multiply to give you whatever a and c multiply to give you, 5x, the 5 and 24, which is 120, and they have to add 34. So you start listing the factors of 120, and we're going to see which ones add to 34. And this will help us factor by grouping. So here it is, 30 and 4. So it'll be 5x squared plus 30x plus 4x plus 24 still equal to 0. Ran out of room. And then we factor by grouping. So then we're going to have these two grouped together. So factor out the common factor of 5x times x plus 6. And then we'll group these together. So plus the greatest common factor between 4x and 24 is 4. And then we'll be left with x plus 6 still equal to 0. Now I'm still not done factoring. Greatest common factor here is a whole binomial x plus 6. So I pull out the whole binomial, and then it's 5x and 4. So 5x plus 4 equal to 0. Now that it's factored, I have a product equal to 0. So either this equals 0 or this equals 0 to solve my equation, because I'm trying to figure out the value of x that makes this whole thing equal to 0. So if either one of these binomials separately equals 0, that's an answer. So if x plus 6 equals 0, I have a solution, and if 5x plus 4 equals 0, that's another solution. So this one's the obvious one, negative 6. And then this one over here is not so obvious, so you need to actually set it equal to 0 and work it out. So you get subtract 4, 5x equals negative 4 divided by 5, and x equals negative 4/5. So if you plug in these two numbers into your original equation, it will make it true. And so that means that's the answer to that equation. Same thing on this one over here. Okay, now we'll get into what's new, which is working backwards. Now I'm going to tell you what the roots of the equations are, and you're going to give me the equation. So notice that when I tell you a root, just like in this one, x, when it's factored, I have x minus 7, x plus 7, and the root's just the opposite. Well, if I tell you the roots, then that tells us the binomial it came from. So if my answer was 6, that means one of my binomials had to be x plus 6. Because when you took x plus 6 and set it equal to 0, oh, I'm sorry, I meant minus 6. X minus 6, because when you set it equal to 0, you added 6 to both sides and got an answer, a root of positive 6. So what we do when you're given the roots is just create a binomial, and it's x minus whatever that root is. And that kind of goes along with the book's definition of a factored form. Whatever the roots are, to get the quadratic, you do x minus the root. So one of our binomials is x minus 6. Now this one, even though it's not a whole number, we can still say x minus 1/3 plus 1/3, because it gives us a negative 1/3. So if we had x plus 1/3 set equal to 0, you'd subtract 1/3 from both sides, and that's how you would get an answer of negative 1/3. And actually, with our quadratics, we want it in standard form, so we cannot have fractions. We can't have fractions or decimals. They all have to be integers. So really, you can't, this isn't the real factor that got us that, because we had to have integer coefficients. The real factor that got us negative 1/3, you can figure out by working backwards. So remember, my final answer would be x equal to negative 1/3. That would be my answer. And so if I'm working backwards to try to get to what binomial I had set equal to 0 to get this, we know we had integers. So I'm going to multiply each side by 3 and get 3x equals negative 1. And I'm going to add 1 to both sides. So 3x plus 1 equals 0. This was my binomial that I set equal to 0 to get an answer of negative 1/3. Because if you see, if we go backwards here, and I said, if my original binomial was 3x plus 1, I would subtract 1, which I was going backwards here, so I added 1. And then I'd add 3x equals negative 1. And then you would divide by 3 to get x equal to negative 1/3. So all we were doing is going backwards and opposite. So instead of dividing by 3, up here we multiplied by 3. Instead of subtracting 1, we added 1 to get back to the binomial that was set equal to 0. So you can do this either way. You can just do it here, or actually figure out what the actual binomial was with the integer coefficients. Either way, you're going to get the right answer, except that with this way, you have to adjust it so we don't have fractions. So let's stick with this first way I did it. And we have to multiply that out. So that's x squared plus 1/3 x minus 6x minus 2 is equal to 0. And then I can see I have a fraction here, so don't combine like terms yet. Let's go ahead and get rid of that fraction. So to get rid of 1/3 to make it a whole number, we're going to multiply by 3. So notice it's not going to affect this right side. And we have to have it as an equation, otherwise we can't do this. So equal to 0, and distribute the 3, so you get 3x squared plus 1x, because 3 times 1/3 is 1, minus 18x minus 6. Now combine like terms, you get 3x squared minus 17x minus 6 is equal to 0. So this is the quadratic that has these two roots. Again, if you find this, instead of using this and then having to adjust with the 3, if you find the actual factor, we can use that too. So we still have x minus 6 and then equal to 3x plus 1. and then just multiply that out. 3x squared plus x minus 18x minus 6, and you'll get the same answer. 3x squared plus 7, nope, just kidding, minus 17x minus 6 equal to 0. So that is the quadratic that gives us those roots. So we'll do one more here. This time I only have one root of 9, so I know to get that root of 9 I had to have an x minus 9. But I don't have any more roots. So because this has to be a quadratic, I have to have two binomials. And since it only has one answer, that just means I need to write the same exact binomial again. So since they're the same factor, they're going to give us the same answer, so that's only one solution. But we have to have two factors in order to make it a quadratic. So x times x is x squared minus 9x minus another 9x, and then plus 81. So notice this is a perfect square trinomial. And we talked about how perfect square trinomials only have one answer. So it's x squared minus 18x plus 81 equal to 0. That's your quadratic that has answers, roots of 9, just 9. There are examples in your book about this as well. It's in the first part of the section. Okay, now we're going to apply our knowledge of quadratics to help us solve some problems here. So this says the area of the triangle is 26 square centimeters. Find the length of the base. So we're trying to find this. So first of all, we're talking about area, which we know for a triangle is 1/2 base times height. So this is the base and this is the height. So my area is 1/2 of x plus 7, my base, times x minus 2. You have to have parentheses because the whole thing is the height. This whole thing is the base, not just one piece. So we can see we're going to have a quadratic here. But I know what the area is. I couldn't solve this because it has 3 variables, well 2, unless I knew one other piece of it. And I do know that my area is 26. So it's 26 equals 1/2 times x plus 7, x minus 2. So since we're solving by factoring, we need to multiply all this out, get it to the same side to get it set equal to 0 so we can solve this. That's how you solve quadratics. So first let's get rid of this 1/2 that's kind of annoying here. We can do that by timesing by 2. So we get 52 equals x plus 7 times x minus 2. We still need to factor that out, FOIL that out. So we have x times x times 2, 7 times x, and then minus 14 equals 52. Get it all to one side, so I'm just going to subtract the 52. And you get x squared minus, combine like terms here, plus 5x, and then minus 66 is equal to 0. And then we just got a factor. So notice we're going to get two answers since it's a quadratic and this is not a perfect square trinomial. So to factor this, these are the easier ones to factor because it has to be x and x. Then you're looking for factors of negative 66 that add to 5. So 66, 11, and 6, and the 11 is going to be positive. 11 plus 11 minus 6. Set each factor equal to 0. So your answers are x equal to 6 and then x equal to negative 11. But since this is a real world situation, you've got to interpret your answer. If x was equal to negative 11, it would make this length negative. That's not possible. So we know that our only answer is x equal to 6. But that's not what they asked for. They asked for the base. So we plug in 6 and get that 13 centimeters is the length of the base. One more example here. Last one, find two consecutive integers whose product is 182. So consecutive, and I'm actually going to change this. I want two even consecutive integers whose product is 224. So consecutive means in a row. So we're going to say let x equal the first number And then the second number is an even integer, consecutive to that. So notice like 2 and 4 are even consecutive numbers. They're 2 apart. 8 and 10 are even consecutive numbers, 2 apart. So if x is the first number, the next consecutive even number is x plus 2. That also works the same way for odds, because odds are also 2 away from each other. So I know that 2 even consecutive numbers, x and x plus 2's product, that's why I'm multiplying them, is equal to 224. So we just have this quadratic that we need to multiply out, get set equal to 0, factor to solve. So I'm going to multiply x times x is x squared, x times 2 is 2x, equals 224. Subtract 224, and x squared plus 2x minus 224 is equal to 0. And now we just have to factor this. So we need factors of 224, whose difference is 2, since this is a negative 224. So I'll go ahead and set up my parentheses. This is an easier one because it's only x squared, not another number, x squared. So we got 1 and 224. We have 2 and 112. 3 and 3 doesn't work. 4 and 56. 6 doesn't work. Let's see if 8 works. 8 and 28. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12 doesn't work. 13 won't work. But 14 does. Okay, so we get 14 and 16. So that means that 14 is negative. So negative 14 and plus 16. So zero product property, set each equal to 0. And x equals negative 16. And x equals 14. So this is not both of the numbers. This is the possibilities for the first number, because remember the second number is whatever is x plus 2, whatever x is plus 2. So since our product is positive, it really can be either one though. So if x is 14, then my other number is x plus 2 is equal to 16. So my answers are 14 and 16, or since a negative times negative equals a positive, if you plug in negative 16 here for the second number, which is x plus 2, get negative 16 and negative 14, and both of them have a product of 224. So there were 2 sets of answers for this one. And that's all I have for you. I had a real-world example, but we'll talk about that on Friday. Have a good day, guys.